I forgot to hit the mic. Okay. Sorry, you guys, about the recording. I just realized that my mic was off, but it's on now. Okay, let's take a look. It says George is cooking an elaborate meal. He can only cook one thing at a time in his microwave oven. His turkey takes 70 minutes. The pumpkin pie takes 20 minutes. The rolls take 30 seconds. And a cup of coffee takes 45 seconds to heat. How much time does he need to cook the meal? And what time does he need to start cooking in order to complete the cooking by 5 o'clock? Okay, so let's take a look at the total time he's going to need. So for the turkey, he needs 70 minutes. Okay. The pumpkin pie, he needs 20 minutes. Okay. The rolls is 30 seconds. So I'm going to go like this, 30 seconds here. And the cup of coffee is 45 seconds. So if I add these together, that would be 75 seconds. But 75 seconds is really the same thing as 1 minute and 15 seconds, right? Because there's 60 minutes or 60 seconds in a minute. So, excuse me. So now if I have 70 minutes and 20 minutes, that's 90 minutes, and plus this 1 minute and 15 seconds. So he needs 91 minutes and 15 seconds. Oops. And 15 seconds. Now they're asking me to say how much time does he need in terms of hours? Okay, so let's do it this way. There are 60 minutes in 1 hour. So if I have 91 minutes, that means I'm going to have 1 hour, 31 minutes, and 15 seconds, right? Okay. So he's going to need 1 hour, 31 minutes, 15 seconds. So let's see if we can put those numbers in and check to see if they work. So 1 hour, 31 minutes, and 15 seconds. Okay, now we want to figure out what time does he need to start doing this. He wants everything ready by 5 o'clock. Okay, so if he wants everything ready at 5 o'clock, if it was going to take him an hour, he would need to start that at 4 p.m., right? Okay, but if he needs an additional 31 minutes, wouldn't he have to start that at 3 p.m. and 29 minutes, right? So at 3:29 is when he would have to do this, right? But he needs also an additional 15 seconds. So if I'm going to take 15 seconds off that time, wouldn't it be 3:28 and 45 seconds? And that's the time he would need to set this thing up. So again, all I'm doing is I'm just kind of working backwards here, right? If he wanted it ready at, say, 5 o'clock, that 1 hour tells me, okay, I would have to start at 4. The 31 minutes would say, I need to take away 31 minutes from an hour. That would tell me I'm left with 29 minutes, right? And if I still have 15 seconds, I got to take those 15 seconds off. So if I was at 29 minutes, now I'm going to be at 28 minutes and 45 seconds. So 3:28:45. And so I'm going to come back over here, 3:28:45, and this should be PM, right? And I'll check my answer, and we got it. Okay. Any other questions anybody has about anything? 15, let's do 15. Okay, so let me go ahead and copy this one here. And let's see if we can't figure it out. Okay, so let me copy this guy. Let's bring it down over here. Let's paste it. Okay, we're trying to fill in the missing digits, right? Okay, so if I'm trying to fill in the missing digits, remember what I'm doing here, y'all. We're subtracting, right? So we're trying to figure out what number do we have to subtract 9 from in order to get 6. So remember, the way I'm going to do this, I'm just going to work backwards. 6 plus 9 would give me a 15, right? That means I got to carry that 1 over here, okay? Now look, I'm going to add again. 5 and 3 would give me 8, plus the 1 that I have here. Wouldn't that give me 9? And then right over here, y'all, 2 minus 1, wouldn't that give me a 1 right there? And so 295 minus 139 should give me 156, right? So let's go ahead and fill those numbers in and check our answers. So we're going to put a 9 right here, is what we said, and we had a 5 over here, and I believe we had a 1 right there, and I'll check it. And hey, we got that part, okay? Let's do the same thing for part B. We'll go about this exactly the same way. Okay, let me copy these numbers. All right, let me copy those, and let's drop them down over here. And again, we're going to go really slow, right? So remember, we're going backwards, right? So again, notice y'all, 9 plus 8 gives me 17. So I got to carry that 1 up here, okay? 8 plus 0 gives me 8, plus 1 more gives me 9. 9 plus 3 gives me 12, carry the 1 over here. 4 plus 8 gives me how much? 12, plus 1 more is 13, and there's the one that we had to carry over, okay? So here, guys, I'm just going to put 3, 2, and 9. Those are the numbers that I'm missing. So let's come back this way, and let's write 3 and 2 and 9, and we'll check our answer, and we got it, okay? Okay, let's take a look at this one here. So let's go ahead and see if we can't figure these parts out. Okie dokie. Let me copy this here, and let me drop it down over here, y'all. Okay, it says perform each of the following operations using the bases shown. Okay, so we have 43 base 5 minus 14 base 5. So 43 base 5, and we're trying to subtract 14 base 5, okay? So think about it this way, y'all. Remember, if I'm dealing with base 5, the numbers that I have here aren't really 10s, they're really 5s, right? So look, I'm going to borrow 1 from that 4. That's going to become a 3. But what I'm borrowing is I'm not borrowing like a 10. I'm really borrowing a 5, okay? So I want you to think about, if you were to add those numbers together, 5 and 3, wouldn't that give me 8? I'm now subtracting 8 minus 4, which is going to give me 4, and 3 minus 1 is going to give me 2. So my answer here would be 2, 4, base 5. Okay, so look, let's try that. Let's check part A first to make sure that we're good. So 2, 4, base 5. So they already have the base 5 there. We just got to put the 2, 4, and we got it. Okay, look, let's do part B. So part B says 3, 3, base 5 minus 2, 4, base 5. Okay, so I'm going to do this the same way. 3, 3, base 5 minus 2, 4, base 5. Okay, I'm going to bar 1 from that 3. That becomes a 2. Really borrowing, y'all, is a 5. So remember, 5 and 3 really gives me 8. 8 minus 4 is going to give me 4. 2 minus 2 is going to go away. So my answer here would just be 4 base 5. Okay. So let's come back over here and let's put a 4. They already have the base 5 there for us. Okay, perfect. All right. And then let's do part C. Okay, so what do we have? 1, 3 zeros and a 1. 1, 1, 2, 3, and a 1, base 2. And we're subtracting 100 base 2. Okay, so let's start subtracting. Well, 1 minus 0 is going to give me a 1. 0 minus 0 is going to give me a 0. Okay, so I'm going to borrow 1 from here. Guys, the 1 that I'm borrowing is really a 2. Okay, so look, I'm going to borrow from that 2. That'll be a 1 there, and that 1's going to come over, right? So now look, 1 minus 1 is going to give me 0. 1 minus 0 is going to give me a 1. So I should have 1,001 base 2. Okay. And let's check. Oh, made a mistake. Okay, let's take a look. Where did I make a mistake? Oh, let me see. Sorry, y'all. Come on, pen. There we go. Let's try this again. So 1, 2, 3, 1, 1, 0. Was it 100? Yeah. Okay. Still base 2. Okay, so that's 1. That's 0. Okay, I'm borrowing from there. So I'm borrowing from there. That's really a 2. I'm borrowing from there. That's really a 2. Okay, so 2 minus 1 is 1 and 1. So maybe, yeah, here we go. I'm sorry, guys. When I'm borrowing, remember, I'm really borrowing a 2, right? So that became a 2, but I'm borrowing 1 from there, so it's a 1. So that becomes a 2. So 2 minus 1 is 1. 1 minus 1 is, or 1 minus 0, I'm sorry, is 1. So I should have 1101. Sorry about that, y'all. 1101, base 2, and there you go. Okay. 23. Let's take a look at 23. Yes. Okay, so let's take a look at 23 here, y'all. Okay. Copy this and bring it downstairs over here. Okay, it says find the greatest common divisor and least common multiple for each of the following group of numbers using the intersection of sets method. Okay, so this is what we're going to do, y'all. We're going to take those numbers 20 and 50 and we're going to break them down. So when I think of 20, you can think of any numbers, right? You can go 4 and 5, you can go 2 and 10. It's really up to you. But I'm going to break down that 10 into 2 and 5. And guys, if we would have said 4 and 5, look, here's 4 and there's 5. Now we're going to do the same thing with 50. When I think of 50, I think of 5 and 10 is 5 and 2. Okay, so I'm going to draw 2 circles here. Okay, so one of them is going to represent 20, the other one's going to represent 50. So the first thing I want to ask is, do we have any numbers in common? Yeah, we got a 2 and a 5 in common. So that 2 and that 5 is going to go inside here. Now in the 20, there was another 2 left over. So that 2 is going to go outside of the intersection, but it's still inside the 20. And the 50 had a 5 left over. So the greatest common divisor are the numbers that we have in common. So the greatest common divisor, the GCD, is going to be 10. Because when I multiply those numbers together, I get 10. So look, let's come back this way. Let me see if I can fill in. Here we go. We're going to say the greatest common divisor here, y'all, is 10. Okay. Now, we want to find the least common multiple. The way we find the least common multiple is we take all the numbers that we see and we start multiplying them out. So we already have the 10, and now we're going to multiply it by the 2 and the 5. So that's 10 times 10. That's going to give me 100. So I'm going to come back right here, and we'll drop 100, and we got it. Okay. And look, let's do the same thing for part B. So 63 and 36. Okay, so first thing I'm going to do, y'all, I'm going to think of my number 63. Okay. I'm going to break this down into 7 times 9. Now I can't break down 7, but I can break 9 down into 3 and 3. The other number we had, I believe, was 36. Let me double check. Yeah, 36. So 36 I know is 6 and 6. And 6 is 2 and 3, and that's also 2 and 3. Okay. So what we're going to do, we're going to draw 2 circles. One of them is going to be the 63. The other one's going to be the 36. So what I want to figure out is, do we have any numbers in common? We got a pair of 3s in both. So those pair of 3s, y'all, is going to go inside. Okay. Now for the 63, I still had a 7. So that 7's got to go over there. For the 36, I still had 2 2s. So those 2 2s got to come over here, right? So remember, my GCD is just the numbers that we have in common. 3 and 3 is 9, right? My LCM is going to be all the numbers. So 7, 3, 3, 2, and 2. So I don't know, let me get my calculator here. 7 times 3 times 3 times 2 times 2. And I'm coming up with 252. Okay. So I will come back this way, and we had 9 here. and we had 252 right over here. Okay. There we go. Okay, now we have 8, 56, and 64. Okay, so we got 3 numbers now. So I got to draw 3 circles, y'all. Okay, 8, 56, 64. So 8 is 2 times 4. 4 is 2 times 2. 56 is 8 times 7. That's 2 times 4. That's 2 times 2. 64 is 8 and 8. So that's 2 and 4. That's 2 and 2. That's 2 and 4. That's 2 and 2. Okay. So again, y'all, now what I'm going to do, I'm actually going to draw 3 circles. So 1, 2, and 3. Okay, I need to look for the numbers that all 3 of them have in common. And it looks like all 3 of them have the 3 2s. So 1, 2, 3. That's what's going to go there. I'm sorry, I should put 8 here, 56, and 64. Now, 8 doesn't have any other factors, so I'm not going to put anything else over here. 56 has one other number. It has a 7. And that 7 is only common to 56 and nothing else. So that 7 will go over there. And 64 still has another 3 2s, and they're only common to 64. So those other 3 2s are going to go right over there. Okay. And now what we're going to do is we're going to look for, okay, what do they have in common? The 3 8s. So the GCD is going to be 8. The least common multiple is going to be all the numbers together. Well, I already know that's 8, and that's got to be 8 too, and that's 7. So 8 and 8 and 7 is, I don't know, but we'll find out, 448. Okay. So my greatest common divisor is 8, and my least common multiple is 48. Or 448, I'm sorry. 8. And we said 448. Boom, there we go. And we got one last one, 11 and 4. Okay. So again, I'll do this the same way. Let's see. We got 11 and we got 4. Now, 4 I can break down into 2 and 2. 11 is already a prime number, y'all. So look, when I draw my 2 circles with an 11 and a 4, the only number that they both have in common is actually a 1. So my 11 will go over here, and the 2 2s will go over here. So what's my greatest common divisor? My greatest common divisor is the only number that they both have in common. And when they don't have anything in common, we can always say they have the number 1 in common. Okay. So they have a 1 in common here. And then the least common multiple would be 44, because we're really multiplying everything together. And we got it. Okay. Good question. Number 30. Let's take a look at number 30. Okay, yeah, let's take a look at this one here. So let me go ahead and copy what we got, so I can take a look-see here. Okay, and let me drop this down over here. Again, this is number 30. So it says, use the Venn diagram pictured with A representing the number of people in an arts class, B representing the number of people in a botany class to express the fraction of elements in the indicated sets as part of the universal sets. Okay, so guys, the first thing I notice about this problem is they're asking me to write a fraction. Okay, so remember, a fraction is going to be part of a whole. So the first thing I need to figure out is what's the total number of students that we got here? Okay, so what I'm going to do is I'm going to say, look, let me take all those numbers and add them up. 24 and 7 and 16 and 12. Okay, so we should have a total of 59 students. Okay, now for part A, when they're asking me to do it for the intersection of the sets, they're asking me how many students are both in the art class and the botany class. Well, 7, but 7 out of 59, okay? For part B, when it has it written like this, it's asking me how many people are in the arts class, but not in the botany class. I'm looking at the number 24. 24, again, out of 59. And then part D says A intersection B. This means complement. So what I'm looking for here, guys, is I know that A intersection B was the number 7. I'm looking for everybody else except the number 7. So I want 24, 16, and 12. If I add those numbers up, y'all, I should get 52 out of 59. So it's going to be 7 over 59, 24 over 59, and 52 out of 59. So look, let me check my answers real quick. 7 out of 59. Okay, and then I forgot the second one, 24. Okay, 24 out of 59. 59. And the last one was 52 out of 59. And oops, why not 52? Why is it not 52? What did I do wrong here? I don't want the 7. I want everybody except the 7. That's 40, that's 52. Wouldn't be 40. What did I do wrong on this last one? Sorry. Let me see. Sorry, y'all. I'm gonna try one more thing. 40? I don't think it's 40 though. No. It's what? 1. A intersection B complement. Oh, what am I doing wrong? A intersection B complement. That would mean everybody but not this part. I don't think it, I don't know. Did you try 1 on yours? And it worked? Huh. Why is it 1 though? A intersection B complement. I'm going to try putting 1, but I don't know why. Yes, why? Okay, hold on. Oh, you know what? I didn't see. I was doing this one here. I was doing A intersection B complement. I wasn't doing part C. I don't know why I missed part C. Okay, this one here is 52 out of 59. Okay, what did I do wrong? I got this part right. Okay, sorry guys, I wasn't looking at the. Let me go back real quick. I don't know why I missed U. I missed that part right there. You know what? Because I didn't do part C. Okay, sorry. Part C. The U means everybody. So 59 out of 59, that's why it's 1, but this here was correct. Okay, so sorry about that, guys. I don't know why I just completely missed doing part C. All right. Any other ones y'all want to ask me about anything? $34. Let's take a look at 34. Okay, it says on a map, 1/4 of an inch represents 4 miles. If 2 cities are 19 inches apart on the map, what's the actual distance between them? Okay, so let's do this. Let's come back this way. All righty. Okay, so it says on a map, 1/4 of an inch represents 4 miles. Okay, so y'all, with these ratio and proportion problems, the first thing I always do is one fraction equals another one. So look, 1/4 of an inch is the same thing as 4 miles. Now we have two cities that are 19 inches apart. So I'm going to put 19 inches here, and I'm going to put X miles right here. So again, the important part is how you set it up. If inches are on the top, inches are on the top. If miles are on the bottom, miles are on the bottom. So look, we're going to just cross multiply. So we're going to take 4 times 19. 76. Okay, so we got 76 is equal to 1/4 times x is a 1/4 x. If I'm trying to solve for x, the way I get rid of my fraction is I multiply by the reciprocal. Okay, so that 4 and that 4 can cancel. And I'm really just taking 4 times 76. So if I do that times 4, that's going to give me 304. Again, these are miles. So right here, y'all, I'm going to write in 304. And we got it. $33. Okay, let's go back to 33. 5/8 of the students at a nearby college live in dormitories. If 6,000 students live in the dormitories, how many students are there in the college? Okay, let's do this. Okay, let me copy this guy here. And let's drop it down over here. Okay, and it says 5/8 of the students at a nearby college live in dormitories. Okay, so we don't know how many students we have. We're going to say X is the number of students. So 5/8. The word of, y'all, means to multiply. So 5/8 times the number of students, we're calling that X, live in dormitories. Well, how many students live in dorms? 6,000 of them, okay? So if we're trying to figure out how many students are going to be at the college, what we need to do here, y'all, the way we solve for X is we multiply by the reciprocal, 8/5, okay? So this 5 and that 5 can cancel, and this 8 and that 8 can cancel, and here's my X, okay? And then, y'all, all I'm going to do is just go straight across. That's 1,000 divided by 5. So 48,000 divided by 5 is giving me 9,600. So 9,600 students are going to this particular college. So I'll come back over here, y'all, and I'll write in a 9,600. There we go. And we got it. Any other ones anybody has about anything? I'm sorry, which one? 25. Okay, let's go back. Let's take a look at 25. Okay, a team lost 9 yards on their first play and gained 3 yards on the next play. Express the total yards gained or lost using an integer. Okay. Alrighty, so let me copy this down here. Okay. Okay, so if a team lost 9 yards on their first play, since they lost those yards, we would say that's a -9. But then they gained 3 yards, so then we have a +3. So remember, if I owe you $9 and I only give you 3, I still owe you 6, right? So I'm going to have a -6 here. And I'm going to check my answer, and we got it. 28. Let's take a look at 28. And let's see. Okay, the temperature in a town drops 9 degrees per hour for 2 consecutive hours. Use an integer to describe the overall change in the temperature. Okay, so look, if it's dropping 9, wouldn't I think about that as a negative 9? And that happens for 2 hours. Negative 9 times 2, that should just be a negative 18, right? Because it's going down 9 degrees every hour, and if it does it for 2 hours, it went down a total of 18. And because it went down, it's a negative 18. Any other questions? I'm sorry, which one? 37. Let's take a look at 37. Okay, let me go ahead and copy this down so we can see if we can figure it out. And it says rewrite each of the following as a decimal. Okay, so let's see if we can do this here. Alrighty. Okay, so y'all, as I'm going through these problems here, this is the easiest way to think about it. Like if I'm looking at part A, 10 to the third means that there's going to be 3 zeros after that number. So I have 8 and then 1, 2, 3 zeros. And we're adding. We're going to have a 4. There's a power of the 2. That means there's going to be 2 zeros after that. And then there's a 5 and there's 1 0 after that. And then there's the number 6. Okay. When I have my powers like this with negative numbers, that just means move your decimal to the left that number of spaces. So I see the number 3, and I'm going to put a decimal right in front of it. And then I see the number 2, and I'm going to move my decimal 2 spaces, okay? So now, if I look at this number here, this is 8,456.32, right? And that's really all I'm doing for this problem. So look, let's do the first part here, 8456.32, 8456.32, and we got it. Okay, let's do part B, C, and D. So look, let's take a look at part B. So for part B, y'all, I'm going to write a 9 and then 4 zeros after that, right? Come on, pen. So 9 and then 1, 2, 3, 4. And then I'm going to have a 6 with 2 decimal places in front of it like this. And then I'm going to have a 2 with 3 decimals in front of it, right? Or not 3, but moving it 3 spaces, I should say, to the left. So what number do I have? I have 90,000.062. So 90,000.062. So 9, 1, 2, 3, 4.062. Check it. We got it. Okay, let's do part C. So part C, 2 with 4 zeros behind it. Okay, so I'm going to write it right here. 1, 2, 3, 4. And then the number 7 and 3 decimal are moving the decimal point 3 spaces to the left. So 1, 2, and then 3. So that number right there, y'all, would be 20,000.007. Okay, and then we got the last part, part D. Okay, so guys, on part D, when we don't see a little number in front of it, you can always pretend that the number in front is a 1. So I'm going to have a 1 and moving my decimal 2 spaces to the left. I'm going to have a 1 moving my decimal 4 spaces to the left. and then I'm going to have a 1 moving my decimal 6 spaces to the left. 1, 2, 3, 4, 5, 6. There we go. Okay. So let's go ahead and write this out. This should be point, and here we go, 0.01. So that's that point, 01, 01, right? I'm just kind of lining them up. So 0.010101, and we'll do that part right here. 01, 01, and 01. Check it, and we got it, okay? Any other ones anybody has about anything? We just did 37, no? $39. Let's take a look at 39. Okay, it says, suppose a carpenter's ruler was marked in 32 seconds. What would the fraction and its decimal equivalent be for the mark on the ruler between 1 and 32 and 2 and 32? Okay, so y'all, what we're trying to do is we're trying to basically find the average of those two numbers. Okay, so 132 and 232. So 132 and 232. So if I want to find the average, the way we find the average of two numbers is we add them together and then we take half of it. Okay. So look, 1 over 32 and 2 over 32 is going to be 3 over 32 times 1/2. If I were to multiply this straight across, that would give me 3 over 64. Okay. So the fraction part of it, guys, should be 3 over 64. So right here, I'm just going to put 3 over 64. Oh, okay, and I still got to do the decimal part. So let me take my calculator. What's 3 divided by 64? 0.046875. 0.046875. Okay, and I'll check it, and we got it. $42. Let's take a look at 42. Okay, it says the value of a yen in Japan in November 13 was given by this equation. Okay, so let's do this. Let me go ahead and copy this guy here, y'all, so we can figure this part out. Okay, and let me drop it down over here. Okay, it says the value of a yen was given by the equation $1 equals 99.925 yen. Okay, so look, y'all, $1 is 99.925 yen. Okay, we're trying to figure out the value of $160. So dollars went on the top here, dollars will go on the top here. This will be our yen. So all I'm going to do here, guys, is just cross multiply. So 1 times x is going to give me an x. And then we're going to take 160 times 99.925. 160 times 99.925. And I'm coming up with 15,988. Okay. So let's see. Let's come back this way. 15,988. There we go. Okay. And then we'll do the second part the same way. So let's take a look. Paulie saw a shirt marked for 2,800 yen. What was the price in US dollars? Okay, I'm going to set it up the same way, y'all. I'm going to go okay, $1 is the same thing as 99.925 yen. This shirt is 2,800 yen. We want to know how many dollars was it. Okay, so again, I'm going to cross multiply. So 2,800 equals 99.925x, and then we'll go ahead and divide everything by 99.925. Okay, so let me take my calculator and let's see, 2,800 divided by 99.925. Okay, we're coming up with this number here, and I believe they're probably going to ask me to round to the nearest cent. So the nearest cent, y'all, would be going 2 decimal places. So the number I'm looking at rounding would be the 2. And the way I know I'm going to round that 2 is I have to look at the number to the right of it. Since it's a 1, I'm not going to round that 2 up. I'm going to leave it as 28.02. So 28.02. And there we go. Any other questions anybody has about anything? And once, going twice. All righty, y'all. So let me go ahead and close this up here. And let me go ahead and stop recording over here.